Hello and welcome to the Concept 22A notes, where we will be discussing ratios and proportions. A ratio is a comparison of two or more things. We will always reduce our ratios. So if our ratio was 2 to 6, we would reduce that to 1 to 3 because 2 is a factor of 6. So an example of the ratios would be 3 to 2 or 1 to 2. So sometimes our ratios are written side by side. Other times they're written as a fraction. A proportion is two ratios that are equal to each other. An example for us would be doing 2x over 3 equal to 4/3. So anytime we set two ratios equal, we are creating a proportion. To solve proportions, we are going to cross multiply. So looking back at our last example, we're going to have 2x over 3 equals 4/3, and we are going to multiply across, so diagonally. So 2x times 3 is 6x, 4 times 3 is 12, and from there we can just solve for our x value, divide, and get x is 2. So we also have such things called equivalent proportions. So there's more than one way to set up any proportion. So two ways we get equivalent proportions are by looking at the reciprocal or flipping the diagonals. So you either flip the fractions or you switch the diagonals. So going back to our last example, we could do 3 over 2x is equal to 3/4. So in that case, all I did was I flipped both the fractions from our original problem. The other option is to switch the diagonals. So we could switch the 3 and the 4 in the diagonal to get 2x over 4 equals 3 over 3. These are equivalent because if we cross multiplied, we will get the same result. No matter what, we are still multiplying the 2x to the 3 and the 3 to the 4 in each of those proportions. In the diagram to the right, Mn over Rs is equal or proportionate to Np over St. So we're going to write three true proportions using the side links. One true proportion would be the 8 over 10 equaling 4 over 6. That's our original proportion. I just plugged in the information from the proportion already given. Mn is 8, Rs is 10, Np is 4, and St is x. As discussed previously, for equivalent proportions, we could flip the fractions. So if I flip it, I would get 10 over 8 equals x over 4. That's my reciprocal. My other option is to switch our diagonals, which gives us 8 over 4 equaling 10 over x. So each of those are going to be exactly the same because they have the same result when we cross multiply. Every time I'll get 8 times x, 10 times 4 that I can solve. On to our next problem. In the diagram to the left, BD over DA is equal to BE over EC, and we want to find BA and BD. So if we want to use the proportion already given, we need to look at our diagram. And the issue we have right now is that we don't have a length assigned to BD. We know B to A is x, D to A is 3. So because the whole distance is x and our bottom distance is 3, I could rewrite BD as x minus 3. It's the whole length minus our 3. So now that we have BD labeled, we can set up our proportion. So x minus 3 over 3 equals 18 over 6. I looked at our diagram, got the BD, the x minus 3, DA is 3, BE is 18, and EC is 6. So, just as we stated before, to solve a proportion, we will cross multiply. What is essential here is that we need to distribute. You must distribute that 6 to the x and the negative 3. So what you end up getting is 6x minus 18 equal to 54. Again, the 6x minus 18 because we had to distribute. Once you add over your 18, you get 6x equal to 72, and you divide to get x is 12. We are still not done though. We want to find BA and BD. We go over to the diagram. Our BA is equal to x, so it will be 12. Our BD is represented as x minus 3. Therefore, 12 minus 3 would give us 9. So in this problem, BA is 12, BD is 9. On our final problem, we have the word problem that states, the blueprint shows a scale drawing of the Statue of Liberty in Las Vegas. This model is 100 feet tall. The actual height of the Statue of Liberty is 305 feet. And we want to know the scale factor of the Las Vegas model to the actual statue. So that is giving us the direction we want to go. We're comparing the model to the statue. So our key information here is 105 feet. I apologize, 150 feet for our model, 305 feet for the actual statue. And so if we want to compare the two, we are going to keep the order it tells us. It wants this model to actual statue. So if I'm comparing the model to the actual statue, I am going to replace my model height with 150 and our statue height to 305 feet. As we discussed before, you always need to reduce your ratio. So these are both able to be reduced by 5. 5 is our common factor. So when I reduce here, we get 30 to 61. So we could represent our scale factor as 30 to 61, or we can change it to a fraction as 30 over 61. And that, there you guys, is our Concept 22A notes.